Hi guys, how are you? Today I'm going to show you how to integrate these kind of functions. You know when you want to integrate by parts and after all your work, the only thing you get is a simpler integral but still another integral to compute? Don't you get discouraged? Yeah, I do get discouraged. Don't you get discouraged? Don't you get discouraged sometimes? Don't you get discouraged when you apply integration by parts and then Jeez, that's so horrible. Oh God, I get so discouraged when that happens. But don't be. Why? Because when you have a function like this, that is a product of a polynomial and either a trigonometric function or an exponential, think about it. If you use integration by parts to differentiate the polynomial and integrate the trigonometric function or the exponential function, now this second function is not gonna vary its level of difficulty, as in the integral of sine or cosine is just cosine or sine with a positive or negative sign. The integral of exponential is just exponential. Nothing's gonna change there. But every time you differentiate a polynomial, you're gonna get a polynomial of a lower degree. So if you keep doing this, you're gonna end up with a polynomial of degree 0, which is just a constant. It's a number. So you will only need to integrate the remaining part, either a trigonometric function or an exponential. So that would be cool. Now, let's try this one. In this case, we have constant multiplied by a function, so the constant I'm gonna just take it outside. Now, as usual, how do we choose the two parts in integration by parts? Remember, basically, when you have a product of two things inside an integral and you want to use integration by parts, you have to split this into two. One part you're gonna differentiate and the other part you're gonna integrate. So how do you choose this? Basically, you choose them so that things are gonna get easier, things are going to become simpler when you differentiate one of them and you integrate the other one. Okay, let's see. What happens with cosine in this case? Are we better off differentiating it or should we integrate it? Well, it doesn't matter really, right? Because the derivative of cosine is minus sine and the integral of cosine is sine, so basically it's the same thing with a positive or negative sign, so it doesn't matter. But what about x squared? If we integrate it, we increase its degree by 1. We're going to get x cubed divided by 3, so we're going to get a polynomial of degree 3. But if we differentiate x squared, we're going to get 2x, so a polynomial with a lower degree. Okay, so let's do this. X squared is going to be the function that we're going to differentiate, and the cosine is going to be what we're going to integrate. As usual, we denote by u the part that we're going to differentiate, so we do that. We differentiate it with respect to x. So the derivative of u with respect to x is denoted by du dx. Now remember that du dx, although it looks like a quotient, it's actually not a quotient, it's not a fraction. It's not a numerator divided by the denominator, but luckily for us we can use it as if it was a fraction. So we can multiply both sides by dx so that we get this. Now on to the part that we want to integrate. So we call dv everything else after the integral sign that is not x squared. That's going to be cosine x dx. Always the part that we're going to integrate, dv, is the one that's going to carry that dx. We'll see why. What's the integral of 1? Well, if you differentiate with respect to x, the integral is going to be x. If you differentiate with respect to v, the integral is going to be v. So basically v is the integral of dv. But what is dv? dv in our case was cosine dx. So v is the integral of cosine x dx, which is the sine. Now putting everything together, applying this formula, we get this. Now we got something slightly simpler, as in, okay, the cosine became a sine, so we still have a trigonometric function that didn't change, but the x squared became an x. So it's a little simpler. So we do that same process again, and we decrease the degree of x by 1, we're gonna get a constant. So we will only need to integrate cosine. So we go on. We're gonna choose what to differentiate and what to integrate. Now we're gonna differentiate x so that we decrease its degree, and we're gonna integrate sine. Okay, so now we do exactly the same thing. We choose the polynomial as the function that we're gonna differentiate, and we choose the trigonometric function as the function we're gonna integrate. So we apply the same process again. U is x, its derivative is 1. dv, what we are gonna integrate, is the sine. So v is gonna be the integral of sine of x, which is negative cosine of x. Therefore, the simpler integral that we had to compute now is gonna become this, using integration by parts. Alright, we're done. Well, not quite, but almost. Notice that now the simpler integral that we had to compute is computed, it's done. So we just have to plug in that expression into the expression of the original integral. Put everything in, and remember, once all the integral signs have disappeared, you have to include the plus c. You can never forget the constant of integration, unless you're computing definite integrals where it doesn't matter. But basically, anytime you use indefinite integrals, you should be including the plus c. Okay, how do we check whether an integral was properly computed? We just differentiate the result, and we should get the original integral. Let's do this. Okay, so here's the result that we got. Now what we want to do is we want to differentiate it, and we should get the original integral. Okay, the derivative of a constant times a function is just the constant times the derivative of the function. So I'm going to keep this 5/3 just aside. The derivative of plus c is going to be 0 because the derivative of any constant is 0. I'm going to use the product rule to differentiate x squared minus 2 times sine, and then I'm going to use the product rule to differentiate x times cosine of x. Okay, finally there's 2x sine of x minus 2x sine of x, so they cancel each other out, and we end up with things that all contain cosine. So we can take cosine as a common factor, and we get cosine times x squared minus 2 plus 2. So we got it! We get x squared cosine of x. Now we're done.